overall coefficient of heat transfer. So how you'll find out U? So U is equal to 1 by summation of R. So what is summation of R? Total heat resistance. Okay. So for example, we'll take about wall. Okay. So in wall you have half inch plaster both side. This is cement plaster, this is brick. So for summation of R for this brick, you'll have R outside plus x1 R1 plus x2 R2 plus x3 R3 plus R inside. These two value you know. Now X thickness, this thickness and resistance of cement plaster. Similarly, X2 thickness of the brick and resistance. This value also you know. So once you know all this, you will find out that value and then you will find out U value. So if you remember for wall we got last time 0.37 which is 37%. What does it mean 37%? Baswaraj, Sama? Hmm. What does 37% means?
So out of 100, this one 37% is the heat emission.
Means if outside is 100 BTU, 37 heat will transfer to inside means 37 BTU.
Yes, sir.
Okay.
Yes, sir.
Then we learned about area. Wall was there. We learned net area and gross area. So this is the wall and in between you have the window. So this was for example 15 feet. Height is 10 feet. So what is the gross area?
Area is 50 square feet, sir.
150.
150. That is 50, no? Sorry.
Yeah, 15, 15.
It looks a 5.
Okay, okay. So it is 150 square feet. And net area is, this is for example 4 feet, this is 5 feet. So net area is how much? Total area, gross area, yeah, minus
Gross area
this area,
minus
20.
this one.
So 130, correct?
Yeah.
Now we will find out external heat source. Okay. Now this is the formula which we discussed last time. Q is equal to UA del T. Okay. What is Q? What is U? You know, right? U is overall coefficient of heat transfer.
Coefficient.
Overall coefficient of heat transfer.
Yes, sir.
Overall heat transfer. U is
Overall coefficient.
coefficient of heat transfer. A is the net area.
Net area.
Delta is the temperature difference.
Yes, sir.
Outside air minus
Inside.
inside air. Outside how much drivable temperature, inside how much you are maintaining. For example, Delhi, we are outside drivable temperature is 109 and inside we are maintaining 75. So difference is how much? 34 degree
34.
Fahrenheit. Okay. So now, so heat transfer, how we will see, for example, any room is there. Let me show you that image once again. Can you see the screen?
Yes, sir.
Yeah. So here, two source of heat gain, I mean, from outside. One is external source. Next is internal source. So external source, what all the things are there?
External, this sun rays
From glass. Okay.
from
Heat
glass.
gain through glass.
Okay. Then wall,
Yes.
then windows.
Yeah. So in this project,
Yes,
we have a one skylight. Okay.
skylight also.
Heat gain through wall. Heat gain through partition.
Glass.
Glass completed. Heat gain through floor,
Skylight. Floor.
ceiling. Okay.
Equipment.
Yeah.
Equipment.
Equipment will come internal. Heat gain through
Yeah.
roof.
Roof.
Okay. Then heat gain through ventilation
Filtration.
and air filtration. Internal, what is there? People,
Internal equipment.
People.
Person, people, equipment,
light,
and lights.
and appliances. Appliances, you have two things. One is kitchen appliances. Second is business appliances. What are business appliances? Like your computer, okay, and the printer. These are business appliances which you are using for your business. Kitchen appliances like your coffee machine, okay, or any heaters, okay, ovens. All those things comes under kitchen appliances. So these are the basic things. Now we will discuss about the external source step by step.
Yes, sir. Sir, infiltration means what you said exactly? Meaning?
Hmm. Okay, 1 minute. See, you have a door and window.
Okay.
Okay. So inside that, some gap will be there.
Oh, okay.
So some unwanted air will come into the space. That is infiltration, unwanted
One
air.
of the code in the window and door.
Yeah, mostly from window and door.
Fine, I got it.
Okay, okay. So heat external in external source. First is glass. So in glass, what all the things will happen? Heat gain through glass. In glass, okay, you will have conduction plus radiation. Okay, because glass orientation and all is different, right?
Yes, sir.
Similarly, heat gain through skylight. Here also same conduction, radiation. I'm writing in short. Third, what happened, Basraj?
External source.
Recording in progress.
Any other device you have joined?
The wall.
Sorry.
Heat gain through wall.
Hmm. So heat gain through wall is transmission heat gain.
This is transmission.
Yeah. So it will be
Transmission.
conduction.
Connection.
Conduction. Okay.
Yes.
Wall, roof, floor, all those things are conduction. Okay. Similar way it will be wall, roof, floor, ceiling,
Partition.
partition. Okay. Another category it will be heat gain through ventilation. Here you'll have sensible heat and latent heat. Okay. Both infiltration and ventilation. It will have same. So step by step we will discuss one. So four category mostly you have. Clear? So now heat gain
Yes.
through glass. So heat gain through glass first is conduction. For conduction, U is equal to UA del T. Now U you know U for the glass already we got it right. So U is equal to 0.8.
Yes, sir.
0.8 means 80% heat will transfer from outside to inside. Okay. And
Yes, sir.
area W1 and W2. This is W1 and this is W2. So both will add it because for conduction we have to add it. For radiation we cannot add because orientation is different. This is north, this is west. So we cannot add in radiation, but in conduction we'll add it. So here it is how much? 20 plus
20 plus 28.
28, 48.
48.
Okay. So del T will be 109 minus 5, 76, 33. If you multiply all this, you will get this much. Any doubt for this?
No, sir. Clear.
Okay. And our project is this one. Okay. We are doing only this project. Next is radiation. Okay. We cannot add area because orientation is different. So Q is equal to URA del H. Little minor difference. Okay. Del H. So here we will understand what type of glass it is used. We have different type of glass like ordinary glass, regular glass, different type of glass are there, shaded glass. Okay. So here we are going for ordinary glass. Okay. Glass factor no shade. So here glass type ordinary. Okay. And for north orientation we are getting 0.75. So here we are taking dark color and we are taking 0.75 U value. Okay, here overall factor for solar heat gain through glass with and without shading definition. So here we are going for
Sir, if it's
dark
in
color.
other direction, this value will get changed
No, this value will remain same.
for
For why
north
we have
or south,
mentioned,
whatever.
but why we have mentioned north because we have to calculate the area for the north window.
Okay.
That is the reason the orientation is mentioned there. Okay, so for north, U is equal to this much, area is equal to 20. You see, this is 20 north. Okay, you know A, you know H, del H, we have to find out from this table. So now for this project, the latitude is for Delhi is 28.56 is the latitude. So we are considering 30 degree north latitude. We are considering this table number 15, solar heat gain through ordinary glass. So now we will see the orientation. Now, if I talk about the orientation here a little bit in terms of solar, we have to understand solar heat gain. No, this is solar heat gain. So if this is my space, this is east, this is west, this is north, this is south. Okay, sun rises in the east. Okay, yes. So morning, this side will affect the direct sun rays. So morning 8 a.m. you will have east side more heat. Evening time, west side you will have more heat. That is 4 p.m. So these are the timing mostly you will see in the calculation. 8 a.m. and 4 p.m. If your orientation is east, we'll go for north and south mostly. You will not find anything in that. Okay,
Sir, here I have doubts, sir.
tell me.
No, normally in general, what we're speaking, the peak sunrise will be, we are saying 12 o'clock, 3 o'clock. No.
That is different. We are talking about the wall. Okay. If you talk about the
Okay.
roof, that time more heat will transfer. We'll discuss that.
Okay,
Okay.
fine. Fine.
So same thing it is mentioned here. Okay, latitude this, and month in which maximum city faces maximum temperature. May 21st to July 23rd is the maximum temperature which India faces. Okay, so based on that, orientation is north. So we will see this orientation north, and our was north, right? So we will take this north and time 8 a.m. or 4 p.m. Both are 14. This is also 14. This is also 14. So 14 will take. So del H is 14. Clear? Any doubt till now?
Sir, in some of the building, one side is glass,
Hmm.
other side is wall. So means 8 timing we have to note that 8 a.m. and 4 p.m.
So for that, we have to see the orientation. Okay. First is orientation. We have to see which side, whether it is wall or glass. Heat will come. Just a minute. Whether it is wall or glass, heat will fall on it. Okay. Solar radiation will fall on the wall on glass. But glass will transmit more heat. Okay. Wall will transmit less heat. That is the only difference. Okay. Any doubt?
Okay, sir.
Yeah. Yeah. So like this, we will find out the Q value, total Q value for the radiation. Any doubt for the glass conduction and radiation? Both we got. Similarly for the skylight. Okay, now skylight, it is on the roof. So
Yes,
the
sir.
timing will be 12 p.m. We have to take the 12 p.m. timing. Okay.
Oh, fine.
Next, we have another glass in the west. So here area, you know, this U values remain same 0.75. Area is 28.7 by 4 was that 28. Now this is del H. We have to find out west. West means what time? 4 p.m. So west
Hmm.
4. You see, this is more, right? If you, for
Yes,
example,
sir.
if you take west 8, the value is 12. Now the value is 164. Okay, so we have to take the higher
Yes,
value.
sir.
164 you have to take because the time and orientation. So this is the Q value, PTU per hour. Clear? Any doubt? Wall is done. Now any doubt for the wall? Sorry, glass. I'll move
No,
on
sir.
to skylight. In skylight, same condition. Okay, skylight is on the roof. So the condition is you have conduction and radiation, solar radiation. So Q is equal to U del T, U value for the skylight. Already we got it initially. Okay, so I'll just quickly show you. Skylight 0.45. Okay, and area is how much? 2 by 2, 4. Area 4.45. And delta is outside minus inside temperature for conduction. Okay, when it comes to radiation, the formula changes. Instead of del T, it is del H. Del H will find out from the table. Table number 15, solar heat gain. So U value for this, we have to see again what type of glass they are using. Here, no shade. In roof, no shade glass is there. So no shade, the value is 0.1. If you have shade anything, 0.75. Now here it is no shade, so 1. So 1 means 100% heat transfer will happen. Okay. For horizontal orientation at the noon time, we have to see. So Q is equal to del H if you see. So this is the time, and horizontal if you see the value is here. Okay. Can you see? 246.
We are considering it to 12, 12, no, sir?
12 we have to take. So
Yeah, 12.
246. 246. So 246 we did. And we multiply all the value you know. This is 1, this is 4, 2 by 2, 4, and this is 246. This is the Q value. Clear? Any doubt? Glass and
No, sir.
skylight both are same. Concept is same.
So for other glass, we have considered only conduction, no? For
See,
second window.
see, first we have considered the conduction. So all area we have added. Okay, if you remember, we have added the area. So here
sir.
we have added the area, right? Window 1 and window 2, we have added
Ah,
in conduction. In radiation, we have
mm,
taken separate, orientation wise. So in
okay, sir.
radiation, we took north side separate, okay, and west side separate.
Got it, sir.
And in skylight, we took it conduction separate. And in here we have one skylight, so we cannot add any other area and all. Okay. And orientation also, we can take one orientation because it is on the roof. Clear?
Yes, sir. So this
Next.
skylight is open.
Oh, not open. Glass is there, no? If you open, rain
Okay.
will fall. All those things will happen. It is just like
Okay.
so what happened for daylight, daylighting means in the daytime, sunlight will fall on this. So that project is designed for that.
Okay.
Okay. In the daytime, you will also see the sunlight entering your house. So for the positive energy.
Okay.
So heat gain through wall. So for wall, we have what type of things? We have conduction. Okay. Wall is conductor. So U is equal to, already we got U. Now
Yes, sir.
wall orientation wise, north orientation different, south different. So that we took it orientation wise. We cannot add area because orientation is different. So then we'll find it here. One important concept is there, as it is transmission heat gain. You will have equivalent temperature plus correction factor. Okay, what is equivalent temperature and correction factor? So this is the factor we will use to find out the equivalent temperature. This table number 19, equivalent transfer temperature difference for dark colored sunlight and shaded wall. Okay, and this you see certain temperature is there, temperature, daily range, all those things it is mentioned. Here you see drivable temperature 95, outside temperature constant 80, room temperature, daily range is 20-degree difference, daily range means, and July 40-degree north. So our project does not hold this value, right? Our project is 30-degree north, okay, and a different daily range was different, not 20-degree, it was around 18 or something like that. Okay, so nothing is matching here. Outside temperature is 109, so nothing is matching to this. Okay, it is only for this location is for New York. So any other city other than New York, you have to add a correction factor. So why, if anyone asks why you are taking correction factor, because the table number 19, which the criteria they have mentioned, all falls for New York City.
Yeah.
So for other city, we have to add the correction factor. Clear? Why we are taking correction
Clear.
factor? U value you know, A you know, del T you have to find out. First is equivalent temperature, second is correction factor. We will find step by step. So uh, orientation is north, wall thickness 9 inch, timing midday plus 2 hour. Okay, this we discuss I think in some of the cases, that heat transfer. Okay, if you see in the coastal area, evening around 4 o'clock, 5 o'clock, outside the house will be cooler, but inside it is more heat, right? Have you experienced that in the coastal areas or in summer season? Okay, you will see outside your house it is temperature is less, but inside it is very high. Have you
Yes,
experienced
sir.
that? That is
Yes, yes, sir.
because of storage effect. Means outside heat was more at for example 2 p.m. Okay, that heat transferring to your inside it took 2 hours. At 4 p.m. inside your house it is more temperature. Outside it will be less. So that 2 hour is your
Okay.
storage effect, storage time. Means the time required from outside heat to transfer to inside. That is called storage effect. Timing, so midday plus 2 hour you have to take. Because we are designing for inside our house. So inside how much temperature is there, that we have to consider. So for Delhi, midday is 2 p.m. and timing is 2 p.m. plus 2 hour storage effect, which is 4 p.m. So we have to calculate for 4 p.m. Clear? So equivalent temperature. So based on the wall thickness, this is the wall thickness. Okay. With respect to weight of the wall, it is written, right? So here it is 4 inch, 6 inch, okay, 9 inch, 12 inch. These are the wall thickness. So for our 9 inch, it will be this one. And we have to see 4 p.m. So value is 4. So this is the 4. Any doubt till now?
Sir, this storage effect, what we are discussing now.
Hmm.
No, that for the 2 or that where it will get stored.
I told you, no, outside temperature, for example, 2 p.m. is more. Okay, generally
Ah,
midday, you have more temperature,
correct.
1 p.m. to 3 p.m. So that heat, it will take 2 hours to transfer to inside. So around 4 p.m., you will have more temperature inside. Okay,
Okay.
so that 4 p.m. we have to calculate here. We have to see the how much you are getting the equivalent temperature in that. So 4 p.m. So 4 p.m. 4 degree Fahrenheit is the equivalent temperature for this north wall.
So this is
Okay,
applicable only in coastal area or all over?
all.
Okay.
I'm giving example only.
Okay, okay, sir. I got it.
Now we have to find the, so this you got, only we have to find out the correction factor.
Correct.
To find out the correction factor. Yeah, any doubt you have, Sama?
Clear, sir.
Okay. So to find out the correction factor, we should know the daily range. In the news report, they will tell the maximum temperature of today, minimum temperature of today, and the difference is the range. Okay, the difference is the range. But Delhi, the range is 18 degree Fahrenheit. Okay, here you see. So 18 degree Fahrenheit is the daily range for Delhi. So temperature difference, outside minus inside, this also So based on these two parameters, we'll find out correction factor.
So this range 18 degree is there, no? 18 degree Fahrenheit. It is any particular month or it is for?
They will consider as a maximum. Okay, which is the
Oh,
maximum temperature and that difference.
okay, okay, sir.
So for different city, if we want to find the range, then
Different?
means for Delhi it is written.
Hmm.
Means in X-ray only we will find the range of
The
different
range and
city.
all online also I showed you. I showed you, right? How to find out from the table and how to find out from the online. Astrometry, that also I showed, right? Online.
Okay.
That way you can find out both.
So this data available only for Delhi?
Our outside minus inside temperature difference was how much? 34. And daily range was 18, right? So this is between 34. And if you combine or 35, you take it. Daily range is 18. Okay, so which is 21. So here it is not 35. So here we'll reduce 1. So 20 we will take it. Okay, we will take it 20. Clear? Any doubt?
Because
Hello.
it is 34, that's why, sir.
That is why one we have to see here. We have to reduce 1.
Mm.
So 30 to 35, 5 divisions are there. 16 to 21, 5 divisions. So 1 you decrease from each.
Okay, fine, sir.
Clear?
So this much accuracy is really required. Huh?
Yes. Required.
Okay.
Required.
No. No, by
Yeah, it
simply
is
you
required.
put the okay, fine.
Yeah. So if the tonnage increases in one room, now this one time you are doing exercise, okay, correction factor. Then after this, you will not find it this table. Okay, once we have to use. So if you make little
Oh,
bit
fine.
higher, everything will change little bit, 5% or something. It will be more.
Okay, sir.
Okay. So here we are getting 20. Okay. I
20.
don't know, in notes might be some different things it will be written. So don't worry. So here, so how much you are getting? So here north wall, how much you got the equivalent temperature? Equivalent temperature you got 4.
Yes, sir,
This you
4.
got 4. This you got 19. So how much? 23. So now you will multiply U is equal to, sorry, U is equal to
No, we got 21, no, sir. Correction factor.
21 we got.
Yeah.
20, no? 21 we